An ancient map depicts Antarctica without its ice. This single artifact suggests a forgotten civilization with global knowledge long before recorded history began. Throughout this journey, you will discover how our entire timeline of human exploration could be wrong. How could ancient sailors chart continents we only recently mapped with satellites? What catastrophic event erased this advanced society from our memory? What does it mean for our past if the world was fully explored thousands of years earlier than we ever believed? What forgotten story does our planet still hold? In the hushed halls of an old Istanbul library in 1929, a forgotten piece of parchment was rediscovered. This was the Piri Reis map, drawn by an Ottoman admiral in 1513. At first glance, it appeared to be a typical chart of its era, but a closer look revealed something astonishing. It showed the eastern coast of South America with a startlingly accurate curvature, a detail European explorers of the time had not yet properly recorded. More incredibly, the map's lower edge seemed to depict a landmass, a northern coastline that looked eerily familiar. It was a profile of Antarctica, but not as we know it today. This was Antarctica without its thick, miles-deep blanket of ice. Admiral Piri Reis himself wrote that his world map was a compilation, pieced together from 20 older source charts, some dating back to the time of Alexander the Great. He was a collector, not the original cartographer. This admission is the key to the entire mystery. The precision of the coastlines, the correct longitudinal positioning, it all points to a source that should not have existed. How could anyone have mapped a continent that would not be officially discovered for another 300 years, and how could they have known its true shape buried under the ice? This is where experts like Professor Charles Hapgood entered the picture. Hapgood, a historian, dedicated years to studying the map's mathematical foundations. He concluded that the Piri Reis fragment was not just a lucky guess. Its accuracy, particularly in plotting latitudes, required a sophisticated understanding of spherical trigonometry, a branch of mathematics that simply wasn't available in 1513, let alone in the ancient world. The map seemed to be constructed using a precise grid system, as if the entire planet had been surveyed from the air. Hapgood proposed a radical idea. The original source maps were the work of a truly ancient, advanced seafaring civilization, a people who had charted the entire globe before a cataclysm, perhaps the same one that encased Antarctica in ice, erased them from history. The implications are staggering. It suggests a worldwide expedition, a coordinated effort spanning oceans, all achieved with knowledge we thought was impossible for our ancestors. This single map fragment forces us to ask a profound question. If one such artifact exists, how many others might be waiting, hidden in plain sight, each one a silent testament to a world we have forgotten? The Piri Reis map was not a singular anomaly. Just 2 years later, in 1531, another cartographic masterpiece emerged that deepened the mystery exponentially. Drawn by the French mathematician Oronce Finé, his world map presents Antarctica with a level of detail that is frankly baffling. This is not a vague, speculative landmass at the bottom of the world. It shows a recognizable continent, complete with deep inlets, flowing rivers, and distinct mountain ranges. These are not surface features. These are the very contours of the land itself, the geographical bones of Antarctica that are now entombed under more than a mile of solid ice. For this map to exist, someone had to have seen this landscape, to have walked upon its soil and charted its waterways at a time when the continent was free of its frozen prison. Modern seismic surveys and core samples tell us the last time Antarctica was largely ice-free was thousands upon thousands of years ago, in a warm epoch long before the dawn of any known civilization capable of such a voyage. How could a 16th-century scholar have possibly imagined such precise, verifiable details? The map's accuracy extends beyond its mere shape. Scholars who have analyzed it note its surprisingly correct longitudinal measurements. Calculating longitude was the single greatest technical challenge for sailors for centuries. The problem was considered so insurmountable that governments offered massive prizes for a solution, which only came with the invention of precise marine chronometers in the 1700s. Yet here, on a map from the 1530s, we see evidence that the original source mapmakers had already solved this puzzle. They possessed a sophisticated understanding of the Earth's curvature and dimensions that should not have existed. So where did Oronce Finé get his information? Like Piri Reis, he was likely working from far older source materials, perhaps salvaged from the legendary Library of Alexandria or other ancient repositories of knowledge that were lost to time. These were copies of copies, faint echoes of a much older, grander geography. Each of these maps is a ghost. They are the faded fingerprints of a people whose name and story have been completely erased from our history books. They force a profound and unsettling question. If our entire timeline of human exploration is wrong, who were these master navigators that charted the entire Earth, and what cataclysm was powerful enough to wipe their memory so completely from the world? The year 1737 brought another cartographic ghost into the world, one that adds a stunning new layer of precision to the mystery. French geographer Philippe Buache published a map of the southern hemisphere that should not have been possible. Like the Phineas map, it depicts Antarctica as a continent free of ice, but it goes much further. Buache's Antarctica is split into two large landmasses, divided right down the middle by a vast sea channel. For centuries, this detail was dismissed as pure fantasy, a cartographer's guess. Then, in the 20th century, we developed the technology to see through the ice. Modern subglacial surveys using radar and seismic readings revealed the shocking truth. Beneath the colossal weight of the ice sheet lies a vast, deep trough, a subglacial basin that perfectly matches the sea channel on Buache's 200-year-old map. He didn't just get the coastline right, he knew what the land looked like underneath. So how did he know? Buache himself claimed his work was based on much older source maps, possibly drawn from lost Greek or even Phoenician documents. This suggests a chain of knowledge passed down and copied for millennia before finally surfacing in his work. The accuracy does not stop at Antarctica. These source maps also portrayed other landmasses with a clarity that defies the era of their supposed origin. The shape of Australia is remarkably defined, and the coastlines of the Americas are rendered with a confidence that European explorers would not possess for another 100 years. This points to a single, inescapable conclusion. The original mapmakers were not just coastal hoppers, they were global voyagers. They possessed the shipbuilding technology to cross the world's greatest oceans and the navigational skill to chart their discoveries with mathematical precision. This was a coordinated effort of exploration, a civilization that viewed the entire planet as its map to be filled. What level of society could support such an ambitious, long-term endeavor? It requires more than just brave sailors. It demands advanced astronomy to navigate by the stars, sophisticated mathematics to calculate position and distance, and a stable, resource-rich culture that can fund and organize expeditions that might last for years. We are not talking about a small tribe in the Mediterranean. We are contemplating a truly global civilization, one with outposts and trade routes spanning the planet. The technological prowess required for such a feat forces us to completely reconsider the narrative of human progress. What if the ascent of civilization is not a straight line but a cycle? What if we are not the first to unlock the secrets of the world, but merely the latest to rediscover them? The true scale of this lost civilization begins to emerge when we examine the seafaring capabilities of our own known ancestors. We celebrate the Phoenicians, who bravely sailed the Mediterranean, and the Polynesians, who populated the vast Pacific by reading the stars and waves. Yet the evidence from these ancient maps suggests an even older, more daring tradition of transoceanic travel. Consider the Uluburun shipwreck, a vessel that sank off the coast of Turkey over 3,000 years ago. Its cargo held treasures from a dozen different cultures, from Baltic amber to African ebony, proving that complex, long-distance trade networks existed in the Bronze Age. But what if this was not the beginning, but merely a faint echo of a much older practice? The original mapmakers would have needed more than just sturdy boats. They would have required a deep, generational understanding of celestial navigation, using the precise movements of stars to guide them across trackless oceans. They would have mastered the hidden rivers of the sea, the great ocean currents that can carry a vessel across the world if you know how to ride them. This was not coastal hopping, this was a science. Legends from across the globe speak of master sailors and sunken lands, from the advanced island of Atlantis described by Plato to the vast Pacific continent of Mu. For centuries, we dismissed these stories as pure myth. But what if they are not literal histories of drowned cities, but a cultural memory, a fragmented echo of that truly ancient seafaring people? Their civilization may have been lost to a cataclysm, but the knowledge they gathered, the charts of the world they created, survived. Copied and recopied, these maps were passed down through the ages, treasured as priceless artifacts by later cultures who may not have fully understood their origin. These charts were their ultimate legacy, a frozen memory of a global network that connected the planet long before our history books said it was possible. If they could map the world, what other knowledge might they have possessed that was lost forever beneath the waves of time? These maps are not the only whispers from that forgotten age. Across the globe, the oldest living cultures carry stories in their oral traditions that mirror the cartographic evidence with startling clarity. For thousands of years, Aboriginal Australians have preserved songlines, intricate oral maps of the land that describe geographical features in precise detail, some of which are now submerged by rising seas. On the other side of the world, numerous Native American tribes tell of ancient migrations across land bridges that vanished beneath the waves at the end of the last ice age. These are not vague legends, they are specific, durable memories of a world that looked very different, preserved through generations without a single written word. Consider the Maori tradition of arriving in New Zealand from a distant homeland called Hawaii. This is not just a mythical place, it is a navigational bearing, a point of origin that speaks to a real, epic voyage across the open Pacific. These stories are the human counterpoint to the cold precision of the Piri Reis and Buache maps. They give us the people behind the charts. What if these ancient maps were not just technical documents, but something more profound? They were likely part of a living tradition, a blend of empirical observation and cultural storytelling. A coastline was not just a line on a parchment. It was the place where the ancestor spirits walked. A mountain range was not just a topographical feature, it was a sacred site of creation. The knowledge of the world was embedded in myth, song, and ceremony, ensuring its survival across countless generations. This changes our entire understanding of what a map truly is. For us, a map is a tool for getting from point A to point B. For them, it was a living story, a sacred text written upon the land and sea itself. The separation we make between myth and history, between science and story, might be a modern illusion. These ancient cartographers saw no such divide. Their knowledge of the stars was woven into their cosmology. Their understanding of ocean currents was part of their epic poems. This is how they could achieve such impossible accuracy. Their mapping was a holistic act, a deep, spiritual connection to the planet they were exploring. The charts that survived are merely the skeleton. The oral traditions are the flesh and blood, the living memory of the civilization that created them. So when we look at a map showing an ice-free Antarctica, we are not just looking at a geographical puzzle. We are looking at a fragment of a story, a single page from a global epic that was lost to time. What other truths about our world are still being kept alive, not in libraries but in the stories of its oldest peoples? The ground beneath our feet holds its own memory of these lost worlds. Modern geology and climatology provide startling physical evidence that the coastlines on these ancient maps are not just accurate, they are anachronistic. They depict a planet from a different age. Ice cores drilled deep from the Antarctic and Greenland ice sheets act as a climate time capsule. By analyzing the trapped air bubbles and chemical isotopes in each layer, scientists can reconstruct a detailed timeline of Earth's temperature and atmospheric composition stretching back hundreds of thousands of years. This data clearly shows that the last time global sea levels were low enough to expose the continental shelves was during the last glacial maximum, a period ending roughly 12,000 years ago. This is precisely when a land bridge like Beringia connected Asia to North America, and when a vast, fertile plain known as Doggerland connected the British Isles to mainland Europe. The ancient maps that show these now submerged coastlines are not guessing. They are remembering. The detailed portrayal of a place like Doggerland, which now lies beneath the North Sea, strongly suggests that the original cartographers walked that land and saw its rivers and hills with their own eyes. They were mapping a real, observable geography that simply vanished as the ice sheets melted and the oceans rose. This correlation is a game changer. It means the source maps used by Piri Reis and Oronce Finé were not just old, they were prehistoric. Their creation is pushed back into a shadowy epoch at the very end of the last ice age, a time we have always considered the domain of hunter-gatherers with stone tools. How do we reconcile this? The geological evidence does not just support the idea of an ancient seafaring culture. It timestamps their existence. Their golden age of exploration must have occurred when the world's coastlines were dramatically different, when you could walk from France to England or from Siberia to Alaska. This was a window of time that slammed shut as the climate warmed. The rising waters that created our modern continents may have been the very cataclysm that drowned their homelands and erased their world from memory. Their charts survived, becoming heirlooms of a drowned planet, passed down until they were finally copied by cartographers who had no idea they were looking at a world 12,000 years out of date. What other secrets are locked in the silent, submerged landscapes beneath our oceans, waiting for us to rediscover the world as it once was? This lost world of the cartographers finds its most tragic symbol in the great Library of Alexandria. More than just a building of scrolls, it was the closest thing the ancient world had to a global data center, a repository designed to gather all known human knowledge under one roof. Its shelves were said to groan with the weight of over 500,000 volumes, including countless maps and navigational logs from every corner of the known world. Scholars like Marinus of Tyre compiled these disparate charts, openly acknowledging that his own work was built upon the foundations of even earlier, now vanished geographers. The library was not a source of original knowledge, but a living chain, a place where this inherited wisdom was studied, copied, and preserved. its systematic destruction over several centuries was not merely the burning of books. It was a lobotomy of human memory, an incalculable loss of our own past. Imagine a single fire consuming the entire internet, every archive and library, leaving only scattered printouts behind. That was the scale of the catastrophe. The echoes of that lost knowledge are still audible in the work of the few scholars who managed to access the library's treasures. Eratosthenes, the chief librarian in the 3rd century before the Common Era, did not just guess at the world's size. He calculated the Earth's circumference using geometry and the angles of shadows cast in 2 different cities. His result was accurate to within a few percentage points of the modern measurement. Such a feat was not a lucky fluke. It was the product of a sophisticated scientific tradition, one that likely drew upon precise geographic data collected by generations of unnamed explorers before him. He stood on the shoulders of intellectual giants whose names are now lost to us. The most famous geographer to emerge from this tradition was Claudius Ptolemy. His world maps, influential for over 1,000 years, were themselves based on the work of Marinus and the older sources housed in Alexandria. Yet what we have today are only medieval copies of copies, pale reflections of the original data. Ptolemy's maps contain glaring errors, like an enclosed Indian Ocean, which suggest he was working with incomplete or corrupted fragments of a much more accurate global geography. The original, pristine source maps were already gone. So what was in those lost scrolls? The startling accuracy of maps like Piri Reis and Buache, which seem to draw from this same ancient wellspring of knowledge, gives us a hint. The Library of Alexandria may have been the last known vault to hold the complete cartographic legacy of that precursor civilization. Its destruction severed our direct link to that world, leaving behind only scattered puzzle pieces that later cartographers struggled to reassemble. We are left to wonder what other wonders of geography, what other maps of forgotten continents turned to ash in those fires. The legacy of Alexandria points us toward an older, seafaring people who may have been the original architects of this global geography. While we search for a single lost civilization, the answer might lie with a network of them, a chain of maritime cultures that passed this precious knowledge down through the ages. The Phoenicians stand as a crucial link in this chain. From their city-states like Tyre and Sidon, these master shipbuilders and navigators established a web of trade routes that stretched from the eastern Mediterranean all the way to the tin mines of Britain. Their voyages were not haphazard explorations. They were carefully planned commercial enterprises, documented in detailed sailing logs known as a periplus. A periplus was far more than a simple list of ports. It was a rich, descriptive guide containing precise coastal profiles, landmarks, sailing times, and notes on currents and safe anchorages. These documents were state secrets, fiercely guarded for the economic advantage they provided. It is easy to imagine how the cumulative knowledge from centuries of such voyages, from countless captains braving the Atlantic swells, could have been compiled into the sophisticated source maps that later surfaced in Alexandria. Their successors, the Carthaginians, expanded this maritime empire further, pushing past the Pillars of Hercules and exploring the Atlantic coast of Africa. The famous Piri Reis map itself notes that its compiler used maps drawn by Christopher Columbus, who, in turn, was rumored to have studied lost Carthaginian charts. This is not a story of one genius cartographer, but of a slow, collective project of discovery spanning millennia. The most tantalizing clues, however, point to voyages far beyond the ancient world's accepted boundaries. Controversial but persistent archaeological finds, like Roman-era amphorae discovered in Brazilian waters or Phoenician inscriptions reported in North America, suggest their reach may have been truly transoceanic. While mainstream archaeology remains skeptical, these artifacts fuel a compelling possibility. What if the Phoenicians and Carthaginians were not just trading in the Mediterranean, but were actively recovering, copying, and adding to even older maps they discovered in forgotten ports or salvaged from shipwrecks? They may have been the curators of this dying geography, the last great seafaring culture to hold the fragments of a complete world map before it was scattered by war and the rise of new empires. This shifts the entire mystery. We are no longer looking for a single Atlantis that sank beneath the waves. We are tracing the ghost of a tradition, a cumulative science of the sea that was built up, lost, partially rediscovered, and lost again. The stunning accuracy of the ancient world maps may not be the product of one civilization's golden age, but the inherited treasure of 1,000 forgotten voyages. This chain of maritime knowledge did not begin with the Phoenicians. It flowed directly into the intellectual heart of the ancient Greek world, where scholars began to systematize what the sailors had discovered. One of the most daring of these early explorers was Pytheas of Massalia, a Greek navigator who, in the 4th century before the Common Era, embarked on a voyage that still sounds incredible. Sailing from the Mediterranean, he reportedly circumnavigated Britain, correctly estimating its triangular shape and vast size. He then pushed further north into a cold, misty sea he called the Cronian Sea, describing a place where the sun barely set and the ocean congealed into a strange, slushy consistency. Modern scholars believe he may have reached the Arctic ice pack or even the coast of Norway. His detailed accounts of the midnight sun and the tidal patterns of the Atlantic were dismissed by later Greek and Roman historians as fantastical lies. But we now know his observations were scientifically accurate. He was not a myth maker. He was a geographer of the highest order, and his work, now lost to us, was studied extensively in the Library of Alexandria. His journey proves that the ancients were capable of voyages far beyond the cozy confines of the Mediterranean, adding concrete, verifiable data to the growing body of global knowledge. The Romans, great engineers and administrators that they were, took this inherited geography and put it to practical use. A magnificent example is the Putinger Table, a medieval copy of a Roman road map from the 4th century. It is not a geographically accurate portrait of the world as we would draw it. Instead, it is a sprawling, elongated diagram, a schematic of the entire Roman world and far beyond, showing a vast network of roads snaking from Britain all the way to India. It depicts cities, rest stops, and mountain ranges, but its most telling feature is its portrayal of the seas. The Mediterranean is shrunken into a narrow ribbon of water, while the Indian Ocean and the Persian Gulf are shown with a clarity that suggests the mapmakers had access to detailed sailing logs from Arabian and Indian merchants. This was not a map for sailors but for imperial bureaucrats and travelers, yet its very existence implies something profound. The Romans did not survey the entire world from scratch. The Putinger Table feels like a simplified, stylized version of a much more sophisticated and complete set of surveys, a diagram based on a pre-existing master map whose true precision was no longer fully understood or necessary for its new purpose. This pattern of copying and corruption is the key to understanding why these classical maps are so frustratingly mixed. They contain brilliant flashes of accuracy right alongside glaring errors and outright myths. The Roman geographer Pomponius Mela, for instance, drew a world map that correctly shows Spain as a peninsula and the Caspian Sea as an inland body of water. Yet he also places mythical islands like the Gorgades in the Atlantic and fills unexplored regions with monstrous races of men. This is not the work of original explorers. This is the work of scholars in a library, piecing together fragments of older, more accurate charts and trying to make sense of the blank spaces with imagination and legend. The errors are not random. They are the telltale signs of a game of ancient telephone, where precise coastlines from a master map become distorted over centuries of copying, and where labels for real places decay into the names of monsters. The mythical elements are the cracks in the facade through which we can glimpse a startling truth. The Greeks and Romans were inheritors, not originators. The truly precise maps, the ones that showed Antarctica ice-free and the continents in their correct proportions, must have existed long before Pytheas set sail or the first Roman road was ever built. Their work points back, always back, to a shadowy epoch of exploration that predates them all, a time when the world was first charted by masters whose names we will never know. Another ghost emerged from the archives in 1957, a document that seemed to rewrite the story of the Americas. Known as the Vinland Map, this parchment appeared to be a 15th century world map, but it contained a stunning addition. In the northwestern Atlantic, it clearly depicted a large, triangular island labeled Vinland. This was a direct representation of part of North America, drawn nearly 50 years before Christopher Columbus's famous voyage. The map's inscription states that it is based on the travels of Leif Erikson and others, explicitly referencing the Norse sagas that describe Viking settlements in the New World around the year 1000. If authentic, this single document proves that European cartographers had concrete knowledge of lands across the Atlantic long before it was considered possible. The debate over its authenticity is fierce, with some experts pointing to chemical analyses of its ink as evidence of a modern forgery, while others argue the evidence is inconclusive. But the map's true power lies beyond the scientific tests. It forces us to confront a deeper question: whether the map itself is a genuine medieval artifact or a brilliant fake. The geographical knowledge it portrays is undeniably real. The Norse did settle in Newfoundland at a site called Elance Orks Meadows, exactly as the sagas described. So how did that specific, verified knowledge make its way onto a world map? The Vinland Map suggests that the Norse discovery was not a forgotten secret. It implies that this information was circulating among scholars and mapmakers, being copied and integrated into the growing body of world geography derived from ancient sources. The map is not an isolated Norse trophy. It is a potential snapshot of that continuous process of updating, a moment when the new world was being stitched onto the old charts. This points to an even more tantalizing possibility. The Norse sagas themselves speak of finding strange artifacts and even people already in Vinland, hinting at prior arrivals. Could the Norse have been following even older sailing directions, perhaps from Irish monks known as the Culdees or other Celtic mariners who braved the northern seas? The Vinland Map, whether real or a clever reconstruction, acts as a crucial bridge. It connects the legendary voyages of the Norse to the broader, more mysterious tradition of ancient cartography. It demonstrates how real geographic data, once discovered, could be absorbed into the surviving fragments of that primordial world map. Each new discovery, from a Viking landing to a Portuguese caravel sighting, was not the creation of a new world, but the rediscovery of an old one. The map is a puzzle piece that fits perfectly between the age of the Vikings and the age of Columbus, showing us that the process of filling in the blanks was a continuous, multi-generational effort. It reminds us that every so-called discovery in our history books might simply be the moment we finally remembered what was already known. Another map from the depths of history deepens the enigma with its bewildering blend of impossible geography and startling precision. Published in 1558, the Zeno Map presents a ghostly portrait of the North Atlantic. It charts Greenland with a shape that is recognizably accurate, and it may even hint at the coastline of North America, a place called Estatiland. Yet scattered across these waters are large, detailed islands with names like Friesland and Icaria, landmasses that simply do not exist and have never been found. This is not merely a map with a few errors. It is a document at war with itself, a chaotic fusion of concrete fact and pure fantasy. The map's own origin story is a tale worthy of a mystery novel. It was published centuries after the alleged voyages of the Zeno brothers, Venetian nobles who claimed to have sailed these northern seas in the 1300s. Their accounts speak of surviving a shipwreck and learning the secrets of the region from a local fisherman. But the map that bears their name feels far older, as if it is a distorted copy of a copy, its true sources lost to time. The phantom islands of Friesland and Icaria are not random inventions. They bear the names of mythical places from Greek legend and Norse saga, suggesting the mapmaker was blending real navigational data with ancient storied accounts of the unknown Atlantic. This is the core challenge of deciphering these artifacts. How do we separate the cartographic reality from the layers of myth that have settled upon it like dust? The most compelling explanation is that the Zeno brothers, or the cartographer who later published the map, were working from a patchwork of much older source materials. They likely had access to genuine Norse sailing charts from their settlements in Greenland and Iceland, which would account for the accurate depiction of Greenland. But they also seem to have incorporated fragments of even more ancient maps, perhaps from the lost Norse settlement of Vinland itself, or from prehistoric seafarers whose knowledge was preserved only in oral tales. These older charts might have shown real, now submerged islands from a time when sea levels were lower, or they may have used symbolic representations of coastal features that later copyists misinterpreted as entire islands. The map is a palimpsest, a parchment where the clear writing of one age has been scraped away and overwritten with the confused interpretations of another. The enduring presence of these phantom lands on maps for centuries afterward had real-world consequences. Explorers like Martin Frobisher would later sail directly to the coordinates of Friesland, convinced it was real, only to find empty ocean. The Zeno Map, in all its confused glory, demonstrates a crucial truth about our lost history. The knowledge of the ancient world was not passed down in a clean, linear fashion. It was a river that branched, silted up, and sometimes vanished underground, only to reappear in unexpected places, carrying both priceless gems and the debris of legend. It forces us to look at every anomaly not as a simple mistake, but as a potential clue, a faded signpost pointing toward a world we are only beginning to remember. These celestial alignments are more than just architectural marvels. They are the silent, stone-bound proof of a global obsession with the stars. Look at the Great Pyramid of Giza. Its sides are aligned with the four cardinal directions with an accuracy that rivals modern engineering. Stonehenge's massive heel stone marks the precise spot where the sun rises on the summer solstice. These are not random placements. They are deliberate, calculated acts that required generations of meticulous astronomical observation. This was a science, and its purpose was deeply practical. For any civilization attempting to map the world, the stars were the ultimate guide. They were the only fixed points in a vast and featureless ocean. By tracking the movements of specific constellations, an ancient navigator could determine their latitude, knowing how far north or south they had traveled. They could hold a true course through the darkest nights and the most treacherous seas. This celestial knowledge was the bedrock upon which any accurate world map had to be built. The Maya in Central America developed a calendar of such complexity that it could predict celestial events thousands of years into the future. the Babylonians mapped the paths of planets with mathematical precision. This was not a coincidence. It was a universal human endeavor, a shared understanding that the heavens held the key to order on Earth. If a prehistoric civilization did indeed map the entire globe, they would have possessed this astronomical wisdom to its highest degree. Their monuments were not just temples, they were observatories and navigational aids, stone computers that encoded the rhythms of the cosmos. Their maps, then, would have been more than just drawings of coastlines. They would have been celestial charts projected onto the Earth, a fusion of land and sky. The knowledge needed to build the pyramids is the same knowledge needed to cross an ocean and chart a new continent. It is a package deal. You cannot have one without the other. This deep, generational study of the stars leaves a permanent mark on a culture. It becomes embedded in their myths, their religion, and their very understanding of time. The surviving ancient maps we have, with their startlingly accurate longitudes, are the final product of this cosmic science. They are the practical application of a wisdom that saw the Earth and the heavens as a single, interconnected system. So when we gaze at these stone circles and pyramids, we are not just looking at ruins. We are looking at the scattered instruments of the world's first cartographers, the fixed points from which they began to measure and ultimately map the entire world. What other secrets of the ancient sky are still locked within these silent stones, waiting to reveal the full extent of a lost global vision? But these grand stone monuments were not the only tools of the ancient masters. Sometimes the most profound evidence of a lost science emerges not from the desert sands, but from the silent depths of the sea. In 1901, sponge divers exploring a Roman-era shipwreck off the coast of the Greek island of Antikythera made a discovery that would shatter our understanding of ancient technology. Amidst the shattered statues and amphorae, they recovered a corroded lump of bronze, its true nature hidden for nearly 2,000 years. It was only decades later, when archaeologists began to carefully clean it, that they saw it for what it was. This was no simple statue fragment. It was a device of breathtaking complexity, a clockwork universe held in the palm of a hand. We now call it the Antikythera Mechanism. This was an ancient Greek analog computer, an intricate assembly of at least 30 finely cut bronze gears, housed in a wooden case and operated by a hand crank. It was not a tool of war or a toy for the rich. It was a sophisticated scientific instrument, a celestial predictor. By turning the crank, its user could track the movements of the sun and moon, predict lunar and solar eclipses with pinpoint accuracy, and even follow the wandering paths of the known planets. This was a mechanical embodiment of the very astronomical knowledge that allowed for precise navigation across the open ocean. It calculated the timing of the Olympic Games and modeled the irregular orbit of the moon using a complex system of gears that would not be seen again in Europe until the 14th century. The existence of such a device implies so much more than just one brilliant inventor. It points to an entire tradition of advanced engineering and scientific thought, a school of craftsmanship capable of designing and building machines of microscopic precision. This was not a fluke. It was a product of a culture that understood gearing ratios, metallurgy, and complex mathematical calculations. If they could build this, what else were they capable of creating? The logical extension of this technological prowess is cartography. A civilization that can construct a machine to model the heavens undoubtedly possessed the tools to translate that celestial knowledge onto parchment. They had the mathematical frameworks to calculate longitude and latitude. They had the engineering skill to design instruments for surveying and star sighting. The Antikythera Mechanism is a surviving fragment of a much larger technological tapestry, one that almost certainly included the creation of highly accurate, detailed maps of the entire world. This single artifact, dating to around 100 years before the Common Era, stands as a silent witness to a level of scientific achievement we never knew existed in the ancient world. It is a physical bridge between the cosmic knowledge of the pyramid builders and the impossibly accurate coastlines on the Piri Reis map. The mechanism's very purpose was to predict the future positions of celestial bodies, the fundamental requirement for any long-distance sea voyage. It proves that the knowledge required for global exploration was not only present but had been mechanized, made portable, and put to practical use. So we are left with a haunting question. If this one device survived by chance at the bottom of the sea, how many other marvels of ancient science were lost, their secrets dissolving into rust and dust? The Antikythera Mechanism is not just an anomaly, it is a ghost, a single, tangible piece of evidence for the technological culture that must have created the source maps for our entire world. Far from the Mediterranean libraries and sunken ships, another echo of this lost science survives in the oral traditions of the Dogon people of Mali. In West Africa, this tribe has preserved a detailed understanding of the Sirius star system that seems to defy their technological means. For generations, their priests have spoken of Sirius B, a tiny, dense, and invisible companion star that orbits the bright Sirius we see in the night sky. They knew it was incredibly heavy, made of a special metal, and that it completed an elliptical orbit every 50 years. Modern astronomy confirms every one of these details. Sirius B is a white dwarf star, so dense that a teaspoon of its matter would weigh tons, and its orbit is precisely 50 years. The problem is, this star is completely invisible to the naked eye. It was only confirmed by Western astronomers with powerful telescopes in the 19th century. So how did the Dogon know? Their own explanation is not one of independent discovery, but of contact. They say this knowledge was given to them long ago by the Namo, amphibious beings who arrived from the sky in a great vessel. This story is often dismissed as myth, but what if we are hearing it wrong? The Dogon tradition does not stand alone. It is a powerful example of how a complex astronomical understanding could be embedded and preserved within a culture's spiritual identity, passed down with remarkable accuracy for untold generations without a single written word. This is not just a story about a star, it is a potential case study for how the advanced celestial knowledge, the kind required to navigate the globe, might have been maintained. If the Dogon could preserve this one precise date, a point across centuries, what stops us from believing that other cultures could have preserved entire navigational systems through song, ritual, and story? The knowledge of Sirius is a fragment, a single piece of a much larger puzzle. It suggests that the ancient world's understanding of the cosmos was far more sophisticated and widespread than our history books allow. The Dogon star lore points toward a time when this celestial science was a global phenomenon, a shared inheritance that informed a worldwide project of exploration. The navigators who charted Antarctica would have needed more than just maps. They would have needed a deep, predictive knowledge of the heavens to guide them across thousands of miles of open ocean. The Dogon memory of Sirius B is a surviving spark from that same great fire of cosmic understanding. It forces us to consider a profound possibility. What if the true legacy of that lost civilization is not just in the maps they drew, but in the stars they taught us to read? The ocean floor is a vast, silent museum of our forgotten past. Off the coast of Japan, the monolithic stone terraces of Yonaguni rise from the seabed, their sharp, 90-degree angles and clean platforms defying natural explanation. In the Gulf of Cambay, the ancient city of Dwarka lies submerged, its stone structures and artifacts scattered across the ocean floor, perfectly matching descriptions from millennia-old Sanskrit texts. These are not isolated curiosities. They are the drowned capitals of coastal civilizations that thrived when sea levels were hundreds of feet lower. Imagine these places not as ruins, but as living, bustling ports. Yonaguni could have been a vital way station for Pacific navigators, its great stone platforms serving as docks or ceremonial centers for a seafaring culture. Dwarka was described as a magnificent city with hundreds of palaces and a prosperous harbor. These were not simple fishing villages. They were the hubs of maritime empires, the nerve centers for the very voyages that would have required and produced detailed charts of the world. When the ice sheets melted and the waters rose at the end of the last ice age, these cities did not vanish overnight. Their inhabitants would have witnessed the slow, inexorable creep of the ocean, swallowing their streets and temples over generations. What would you do if your entire world was being erased by the sea? You would save your most precious possessions, and for a maritime culture, the most valuable treasure was not gold but knowledge. Their maps, their sailing logs, their periplus describing ocean currents and safe harbors, these were the keys to their survival and their legacy. These vital documents would have been the first things evacuated, carried inland by refugees and preserved in new cultural centers. This is the likely journey of the source maps, the original charts drawn from direct observation by the navigators of Yonaguni or Dwarka, were copied and recopied. They became sacred heirlooms traded along surviving land routes, eventually finding their way to the libraries of Alexandria or the vaults of Ottoman admirals. The maps we have today are not the originals, but the echoes of a desperate exodus, the saved knowledge of a drowning world. Modern technology adds a stunning layer of proof to this theory. Sonar scans of the underwater structures at Dwarka reveal a sprawling city plan with river channels and massive walls. When these submerged layouts are compared to ancient cartographic references in Indian texts, the correlations are striking. The maps remembered the city as it was, not as the ocean found it. This physical evidence on the seafloor validates the accuracy of the ancient geographical knowledge. The ruins are the bones, and the maps are the memory. Together, they tell a story of a global cataclysm that fragmented a worldwide network of seafaring cultures, forcing them to pass their greatest achievement, a map of the entire planet, down to us, like a message in a bottle from a lost age. What other drowned metropolises with their own libraries of lost maps are still waiting to be found beneath the waves? Yet another echo of this lost world emerges from the most isolated inhabited island on Earth. Easter Island stands as a solitary sentinel in the vast emptiness of the Pacific, thousands of miles from any other shore. Its famous moai, the towering stone giants with their stoic gazes, are a testament to a complex and capable society. But the mystery runs deeper than the statues. The island is also home to Rongorongo, a unique and undeciphered script, the only written language found in all of Polynesia. The presence of a writing system on such a remote island is a profound puzzle in itself. How did this knowledge arrive there, and from where? The oral traditions of the Rapa Nui people provide a haunting clue. They speak of a homeland called Hiva, a large and fertile land that slowly sank beneath the waves, forcing their ancestors to flee in great voyaging canoes. This is not just a story of migration, but of cataclysm. If Hiva was real, it was not simply another Pacific island, but potentially a significant landmass, a central hub in a larger network. The settlement of Easter Island is one of archaeology's greatest enigmas. To reach this tiny speck of land required an epic, deliberate voyage across open ocean, a feat of navigation so precise it seems to defy logic. This was not a drift voyage. It was a calculated colonization, implying the navigators possessed detailed knowledge of currents, winds, and the star paths that led to this remote outpost. Their legends of a sunken homeland align perfectly with the geological evidence of rising sea levels at the end of the last ice age. Could Hiva have been a remnant of that lost world, a surviving piece of a Pacific continent like the legendary Mu, or simply a large, fertile island now submerged? If the Rapa Nui originated from such a place, they would have been inheritors of a deep maritime tradition. Their voyage to Easter Island was not the beginning of their journey, but a desperate continuation of it. They would have carried with them the most vital tool for survival, the accumulated navigational wisdom of their ancestors. This knowledge would have included star charts, understandings of swells and bird migratory patterns, and perhaps even mental maps of the Pacific that have since been lost. Easter Island's location is not random. It sits at a navigational crossroads in the Pacific. Its position makes it a potential waypoint, a stopping point for ancient voyagers traveling immense distances between South America and the islands of Polynesia. The presence of sweet potatoes, a crop native to the Americas, on Easter Island long before European contact strongly suggests that these transoceanic voyages were real. The Rapa Nui were not isolated. They were the guardians of a remote station in a vast, ancient web of exploration. Their stone giants do not just face inland to watch over their people. They turn their backs to the endless sea, as if forever guarding the memory of a homeland that vanished beneath the horizon, and the secrets of the seafaring civilization that first mapped our world. High on the arid plains of southern Peru, a vast canvas of desert stone holds one of archaeology's most enduring riddles. The Nazca Lines stretch across hundreds of square miles, a breathtaking gallery of geometric shapes, straight lines that run to the horizon, and colossal depictions of animals and plants. From the ground, they are shallow grooves in the reddish soil, but from the air, their true majesty is revealed. For decades, the prevailing theory was that these were sacred pathways, walked by priests during elaborate rituals. But this explanation feels incomplete, like trying to describe an entire library by looking at a single page. What if these giant drawings were not just for ceremony, but for survival? A growing body of research suggests the lines functioned as a sophisticated hydrological map. In one of the driest places on Earth, water is life, and the Nazca Plateau sits atop a complex network of underground aquifers. Astonishingly, many of the largest and most complex figures, like the hummingbird or the monkey, are positioned directly over major fault lines where subsurface water would naturally rise closest to the surface. The lines themselves may have acted as conduits, channeling rare desert rains and directing the precious flow. They were a permanent, unmissable record of where to find water, a map written on the land itself for the community that knew how to read it. This transforms the lines from abstract art into a practical, life-sustaining technology. The precision required to create them is staggering. How do you lay out a perfect spiral or a straight line miles long without modern tools? The builders possessed a form of advanced surveying, using simple stakes and chords to achieve a level of accuracy that would challenge engineers today. This was not a skill developed overnight. It hints at a deep, inherited knowledge of geometry and land measurement, possibly passed down from a much older culture that had mastered the science of cartography. If the lines chart the hidden water veins of the desert, could they also point to something beyond the horizon? Some researchers propose they are part of a larger cartographic system. The long, arrow-styled runways seem to point toward distant mountains or specific celestial events, acting as permanent navigational markers. They could have been used to demarcate territory for different clans or to map out trade routes across the harsh landscape. This idea connects the Nazca Plateau directly to the mystery of the ancient maps. It suggests a different philosophy of mapping, one that was not confined to parchment, but was instead inscribed directly onto the body of the Earth. These geoglyphs are a terrestrial echo of the same impulse that created the Piri Reis and Buache maps, a profound need to understand, document, and navigate a vast and often unforgiving world. The true function of the lines was likely a fusion of all these things: ritual, resource management, and astronomy, intertwined into a single grand design. They stand as a monumental testament to a people who saw their environment as a living text to be read and a canvas to be marked. In the silent desert, they left behind a map that was not meant to be carried in a pocket, but walked with your feet and seen with your soul, a permanent reminder that the urge to chart our world is written deep within our past. Deep in the Anatolian plains of Turkey, the stones of Göbekli Tepe whisper a secret that rewrites human history. This sprawling complex of carved pillars and circular enclosures was erected over 11,000 years ago, a time when we are told humans were simple hunter-gatherers. Yet here, multi-ton blocks of stone were quarried, shaped, and arranged with clear purpose and stunning artistry. The site is not a haphazard collection of rocks. Its T-shaped pillars are aligned with celestial events, its architecture a permanent record in stone of a sophisticated understanding of the stars. This was the work of a society with a shared vision, a collective memory, and a level of organization we never attributed to people of that era. If they could orchestrate the construction of such a monument, what other knowledge did they possess? The precise astronomical alignments at Göbekli Tepe are a form of mapping. They charted the heavens, marking the solstices and the movements of constellations. It is a small, logical step to suggest they were also mapping the Earth. To source the stone, to organize the labor, to plan a site that would last for millennia, they must have had a mental geography of their world, a detailed understanding of the land, its resources, and its routes. This was likely the dawn of cartography, not on parchment but in ceremony and stone. This knowledge was not confined to one hilltop in Turkey. The same impulse appears across the globe, separated by oceans and millennia. The massive stone circles of Karnak in France, the haunting dolmens of Korea, the mysterious alignments of Nabta Playa in the Egyptian desert, all speak a common architectural language. They are all products of a megalithic age, a period where cultures with no conceivable contact independently arrived at the same idea: to build colossal, enduring monuments tied to the sky. Or was it independent? The sheer similarity in design and purpose raises a profound possibility. What if this was a shared knowledge base, a foundational understanding of geometry, astronomy, and engineering that spread across the ancient world? This global network of stone suggests a precursor civilization, or at the very least, a connected web of cultures that exchanged ideas along forgotten trade routes. The maps that later surfaced in Alexandria or Constantinople may have their true origins here, in this lost epoch of megalithic builders. Their legacy was not the stones themselves, but the knowledge encoded within them. The celestial maps allowed for navigation. The understanding of geometry allowed for surveying. The social organization allowed for long-distance travel and the transfer of information. This was the fertile ground from which a true world map could eventually grow. The builders of Göbekli Tepe and the other megalithic sites were not primitive. They were the architects of the first global culture, a civilization of the mind whose greatest monument was not a single temple, but the very idea that the entire world could be measured, understood, and ultimately charted. This interconnected web of ancient knowledge finds one of its most powerful expressions far to the east. While European libraries burned, the Silk Road thrived as a living nerve center of intellectual exchange. For over 1,000 years, this vast network of caravan routes carried more than just silk and spices. It was a continuous conduit for ideas, where geographic knowledge was one of the most precious and secretive commodities. A stunning example of this is the Da Ming Hunyi Tu, the amalgamated map of the Great Ming Empire, created in China in the 14th century. At first glance, it is a map centered on the Chinese Empire, but its scope is breathtakingly global. It accurately depicts the shape of Africa, showing the continent with a recognizable southern tip, a geographic fact that European maps would not correctly show for another 100 years. It charts Europe and names distant places like France and England. This was not a map born from Chinese exploration alone. It is a cartographic mosaic pieced together from Arab sailing charts, reports from Persian merchants, and fragments of knowledge gathered from every corner of the known world, all flowing east along the Silk Road. This map is physical proof that long before the age of European exploration, a sophisticated and surprisingly accurate picture of the world was being assembled through international collaboration. The exchange was not merely technical. Chinese legends and official histories speak of a distant land across the Eastern Ocean called Fusang, described in such detail that it seems to be more than myth. Ancient texts recount the journey of a Buddhist monk named Hui Shen, who in the 5th century sailed to a land 20,000 Chinese miles to the east, a place with towering Fusang trees and a civilization unlike any in Asia. The descriptions of the people, the plants, and the geography have led many researchers to propose a startling conclusion. Fusang was very likely the west coast of the Americas. If true, this suggests that transoceanic contact and the exchange of geographic data were happening across the Pacific, completely independent of the Atlantic world. The implications ripple back to our core mystery. The stunningly accurate world maps that appeared in Europe during the Renaissance were not sudden inventions. They were the final product of this millennia-long, planet-wide project of knowledge sharing. The Silk Road connected the cartographic traditions of China, India, Persia, and the Arab world. The Arab scholars, in turn, had preserved and expanded upon the geographic works of the Greeks, which themselves were inherited from even older sources like the Phoenicians. Each culture added its own piece to the puzzle. A Chinese map might contribute the accurate shape of Southeast Asia. An Arab portolan chart would provide the detailed coastlines of the Indian Ocean. A surviving classical text might offer a glimpse of the far north. All of this information was compiled, copied, and traded, slowly building towards a complete picture. The world was not discovered by one culture in one great age of exploration. It was remembered, piece by precious piece, through the collective memory of humanity, passed hand to hand along the silk routes that connected the world. This changes the entire narrative. It means our planet's geography was never truly lost, only fragmented. Its secrets kept alive in 1,000 different places, waiting for the moment when the pieces would finally be put back together. The open ocean was their map and the stars were their compass. While we have been tracing the lines on parchment, another civilization was charting the world in an entirely different way. The Polynesian voyagers did not cross the Pacific by accident. They embarked on deliberate journeys across thousands of miles of empty sea, guided by a science so refined it was woven into the very fabric of their culture. They navigated by the star paths, the precise rising and setting points of specific constellations that acted as celestial highways across the water. They read the subtle language of the ocean itself, interpreting the shape and rhythm of swells rebounding from unseen islands, and followed the flight paths of birds that always returned to land at dusk. This was not guesswork. It was a rigorous, repeatable method of wayfinding, a living cartography passed down through generations of master navigators. Their most fascinating artifacts are the stick charts, intricate frameworks of twigs and shells that look like abstract sculptures to the untrained eye. These were not maps to be held up to the light and followed like our own. They were mnemonic devices, physical models that represented the interaction of ocean currents and swells around specific island groups. The curved twigs mapped the waves and the small shells marked the islands. A navigator would feel the chart with his hands, memorizing the patterns, and then carry that mental map in his mind for weeks at sea, comparing it to the real motion of his canoe. This knowledge was so vital, so powerful, that it was often considered secret, passed orally from teacher to apprentice in a sacred chain of custody. The Polynesian achievement demonstrates with stunning clarity that a civilization does not need parchment, ink, or even a written language to map the world with breathtaking accuracy. Their entire geography existed as a living library in the minds of their navigators and in the shared stories of their people. This offers a profound model for how a prehistoric global civilization could have accomplished the same feat. If the Polynesians could settle a triangle of oceans spanning from Hawaii to Easter Island to New Zealand using only mental maps and observed patterns, why not an even older, more widespread culture? The star paths they used are eternal. The ocean currents they rode are ancient. The knowledge required to traverse the planet has always been there, written in the sky and the sea, waiting to be read by those who know how to look. The legacy of the Polynesian voyagers is a powerful reminder that the greatest maps are not always drawn on paper. They are carried in memory, sung in stories, and felt in the rhythm of the waves, a timeless navigation that could have guided the first explorers to every corner of the earth. Deep within the Amazon, a hidden world is emerging from the shadows. For centuries, the dense rainforest canopy concealed what was believed to be a pristine wilderness, untouched by large-scale human hands. But recent LiDAR technology, a form of aerial laser scanning that pierces through the vegetation, has revealed a stunning truth. The forest floor is etched with vast geometric patterns, enormous earthworks in the shapes of perfect circles and squares, and complex networks of causeways and roads. These are the Amazonian geoglyphs, and they tell a story not of a wild jungle, but of a managed, engineered landscape created by sophisticated societies. These were not just simple villages. The scale and precision of the earthworks point to a people with a shared social structure, capable of organizing large labor forces to reshape their entire world. They built massive ceremonial centers and complex irrigation systems, turning the challenging rainforest into a productive, human-centered environment. These structures were likely territorial markers, defining the domains of powerful chiefdoms, and sacred spaces where their understanding of the cosmos was physically inscribed upon the land. This deep, intimate knowledge of their territory was a form of cartography in itself. To plan and construct these colossal features required an advanced mental map of the terrain, its resources, and its hydrological cycles. They knew the land so thoroughly they could bend it to their will, creating a permanent record of their presence that would lie hidden for 1,000 years. But what if their influence did not stop at the edge of the jungle? The discovery of trade goods like polished stones and specific types of pottery, found hundreds of miles from their source, suggests these Amazonian societies were part of extensive exchange networks. If goods could travel, so could knowledge. Imagine a trade route that stretched from the heart of the Amazon to the Andes, where information was a currency as valuable as any gem. A traveler from a geoglyph-building culture could describe the great rivers, the unique wildlife, and the very shape of the continent's interior to mapmakers in the highlands. This geographic data, this intimate understanding of a vast and mysterious land, could have been compiled, copied, and passed along, eventually finding its way into the same stream of ancient knowledge that informed the maps of Piri Reis and Oronce Finé. The Amazonian civilizations were not isolated islands in a green sea. They were likely vibrant, connected nodes in a pre-Columbian world that was far more interconnected than we ever dreamed. Their hidden earthworks add a crucial, vibrant piece to the puzzle. They prove that advanced societies, capable of large-scale environmental engineering and possessing deep geographical wisdom, flourished in places we once wrote off as empty. If the Amazon was mapped and managed, then the entire New World was a known world long before Columbus set sail. The true terra incognita is not on any map, but in our own understanding of the past. Carved into 3 small clay tablets in a Transylvanian village, a set of mysterious symbols from over 7,000 years ago holds a silent challenge to our history. Discovered in 1961, the Tartaria Tablets were found alongside ancient human remains, suggesting they were items of profound importance, perhaps even buried as grave goods for a person of high status. The symbols etched onto their surface are not random scratches. They include a series of abstract marks, a horned animal, and what looks like a branching, plant-like structure. To many archaeologists, these are ritual objects, perhaps linked to early religious practices, but a handful of researchers see something else entirely. They propose that these symbols are not just decoration or proto-writing, but a form of notation, a code for recording the physical world. That branching pattern could be a river delta. The repetitive marks might signify distances or counts of days traveled. The animal could represent a specific territory or a clan's totem. If this interpretation holds even a grain of truth, then these humble tablets are not merely ritual art. They are the earliest surviving maps. This idea places the very origin of cartography not in the Bronze Age, but deep within the Neolithic, with the Vinca culture that created them. This was a society already demonstrating remarkable sophistication with organized settlements, advanced ceramic technology, and these very symbols that hint at a symbolic communication system. Mapping for them would not have been about crossing oceans, but about survival and identity. It would have been about marking hunting grounds, tracing the paths to fresh water, and defining the sacred spaces within their known world. Their map was not a chart of continents, but a diagram of their life, etched into clay for safekeeping. The controversy surrounding the tablets is a powerful reminder of how we interpret the past. We easily accept that a cave painting of a bison is a representation of the animal, but we resist the idea that a patterned symbol could be a representation of a landscape. This resistance forces a crucial question. What if the first step toward mapping the world was not a grand chart, but a simple mark on a clay tablet, a way of saying, we were here, this is our place? The Tartaria Tablets represent that potential moment of inception, the spark of an idea that would, over thousands of years, evolve into the breathtakingly accurate world maps that defy explanation. They are a whisper from the very dawn of civilization, suggesting that the urge to chart our surroundings is as ancient as settled society itself. The dramatic warming that ended the last ice age was not a gentle transition. It was a planetary upheaval that reshaped the very face of the Earth. As the massive ice sheets melted, they unleashed colossal volumes of water, causing global sea levels to rise by nearly 400 feet over just a few millennia. Entire continental shelves vanished, and coastlines retreated for miles, swallowing the very lands where early maritime civilizations would have built their ports and cities. This was not a slow, imperceptible change. For the people living through it, it was a terrifying, relentless cataclysm, a slow-motion deluge that erased their world generation by generation. Imagine watching the ocean claim your ancestral home, your farmland, your sacred sites, knowing it will never return. What would you do to ensure your knowledge survived? This existential threat may have been the ultimate catalyst for the creation of durable, precise world maps. They were not just tools for navigation, but a desperate act of preservation, a way to record a geography that was literally disappearing beneath the waves. The most vital knowledge, the charts of coastlines and ocean currents, would have been copied onto the most durable materials available, like treated animal skins or etched clay tablets, and carried inland by refugees fleeing the rising waters. This forced migration would have funneled this precious geographic data into highland regions and river valleys, places like the Nile, the Tigris and Euphrates, and the Indus, which were naturally protected from the encroaching seas. It is no coincidence that the first great civilizations of our recorded history emerged in these exact areas. They were not necessarily the originators of all their knowledge. They may have been the inheritors, the safe havens where the salvaged maps and wisdom of a drowned world were preserved, studied, and finally integrated into a new cultural context. This scenario gives profound new meaning to the flood myths found in virtually every culture on Earth. The story of Noah's Ark is not just about saving animals. It is a metaphor for saving knowledge. The Babylonian epic of Gilgamesh, the Hindu tales of Manu, the Aboriginal stories of the Dreamtime floods, the Native American legends of the Great Deluge, all these are not mere coincidence. They are the cultural scar tissue, the collective memory of a real, global event that shattered the human world. The Ark in these stories is not just a boat. It is a library. It is the vessel that carried the seeds of knowledge, the maps, the star charts, and the stories of the old world into the new. The cataclysm did not just destroy. It also acted as a filter, ensuring that only the most vital, most carefully preserved information would survive. This could explain the stunning accuracy of the ancient maps that later surfaced. They were not the work of a single golden age, but the legacy of a desperate rescue mission, a final, brilliant mapping of a world on the brink of dissolution, a message in a bottle tossed from a sinking ship across 12,000 years of time. These scattered clues from maps, myths, and monuments cannot be understood in isolation. The true path forward lies in weaving them together through an interdisciplinary approach, combining the strengths of archaeology, geology, astronomy, and linguistics to solve this single, sprawling mystery. Imagine a geologist pinpointing the last time a coastline on an ancient map was above water, while an archaeologist excavates a newly discovered settlement on that same submerged shelf. This correlation of data from different fields provides a powerful validation, transforming a curious line on parchment into a time-stamped record of a lost world. Linguistic analysis offers another crucial key. By studying the roots of ancient place names across different cultures, scholars can trace the ghostly routes of contact and migration. A name for a river in South America that shares a startling phonetic similarity with a word from a Mediterranean language could be a fossilized memory of a transoceanic voyage, a whisper of connection preserved in syllables. This method moves us beyond speculation and into the realm of verifiable evidence. Astronomy provides a fixed clock in the sky. The precise celestial alignments encoded in monuments like Göbekli Tepe or the Nazca Lines can be dated with extraordinary accuracy. When these astronomical dates align with geological evidence of climate change and archaeological evidence of cultural shifts, a solid, multifaceted timeline begins to emerge. This holistic perspective forces us to abandon the idea that any one expert holds the entire truth. The geologist cannot decipher a myth, nor can the linguist date an ice core. The story of this lost civilization is a jigsaw puzzle where the pieces are held in different university departments, in different museums, and in the oral traditions of different peoples. Only by sharing these pieces can we hope to see the full picture. This collaborative effort is our best chance to finally answer the questions these ancient maps have posed for centuries. We are no longer just staring at the puzzle. We are beginning piece by piece to put it together. Our journey across these impossible maps comes to an end, yet the mystery only deepens. From the ice-free coastlines of the Piri Reis chart to the mental cartography of the Polynesian Voyagers, we have traced the ghost of a civilization that saw the whole Earth as its map. These artifacts are not merely errors or lucky guesses. They are stubborn fragments of a forgotten reality, challenging the very timeline we have written for ourselves. They suggest that the human drive to explore, to navigate, and to chart our world has roots that sink far deeper into the past than our history books dare to admit. So much knowledge has been lost to the rising seas, to library fires, and to the slow erosion of time. What other wonders of that ancient world remain hidden, buried beneath deserts, or waiting in the uncharted depths of our own archives? If this glimpse into a lost chapter of human history has sparked your curiosity, we would love to hear your thoughts. Share your own theories and questions in the comments below, and subscribe to continue unraveling the greatest enigmas of our past. The story of humanity is far from complete, and every new discovery reminds us that the past holds more secrets than we